Let's quickly talk about how displacement vectors overlay a map differently than velocity vectors. So be careful if you draw a map and you put velocity vectors on it and displacement vectors. Displacement vectors are easy. Let's say that this road is 10 meters across, and I want to overlay my vector information. That means I want to put my vector information on top. Let's say the person crossed the road, and this represents 10 meters. I mean, that's a physical representation of travel here. And then let's say the person traveled west 3 meters. These fit exactly with the map. So you can tell this person crossed the street and moved 3 meters to the west. And you can find his total displacement using the Pythagorean theorem. Now let's talk about velocity vectors. Velocity vectors are different. Don't get confused. If you see a velocity vector that looks like this, and let's say it's 3 meters per second, don't think that this person traveled 3 meters. This means he was traveling at 3 meters per second. So again, if you're going to put this on the map, that represents speed. The person could be here, the person could be here, the person could be here, the person can be anywhere. That's just the person's speed at a particular time. So don't think that this means how far they travel. This velocity vector, let's say it's 5 meters per second. That velocity vector does not mean the person started on one side of the street and landed up on the other side of the street. It does not mean that. It's a velocity vector. It merely represents how fast you're moving in which direction. Again, it doesn't matter if you're here. It doesn't mean if you're here. It is instantaneous. It has nothing to do with where you were. It just has everything to do with how fast you were going.